Hello chemistry students. We're going to continue talking about compound stoichiometry, more specifically percent composition. Now when we talk about percent composition, with any percentage problem, you are comparing the part to the whole. In any percentage problem, that's what you're doing, comparing the part to the whole. In chemistry, we do this based on mass. So the numbers we're comparing are based on mass, not by the number of atoms. We do not compare it to the number of atoms. To find the percentage of certain elements in a compound, you will compare the mass of the element to the mass of the entire compound. Okay, now let's talk about our steps in percent composition. First step is you write the correct formula. We've been doing this since Unit 7. First problem is going to be, what is the complete percent composition by mass of potassium carbonate? So the first thing we need to do is write out our formula. Potassium is right here, and it is the letter K. So that's what I will write, the letter K. It is in group 1, which means it has one valence shell electron. It is easier for it to lose 1 than gain 7, so losing 1, that's its oxidation number. Now we need to look for carbonate. If it ends in 8, we find that on the polyatomic ions chart. In carbonate is CO3 with a -2 charge. So CO3 with a -2 charge. Now we have to crisscross. This 2 goes down by the potassium, and this 1 goes down by the carbonate, and since there's only one of them, we do not have to put parentheses. So the formula for potassium carbonate is K2CO3. Step 2, we need to find the formula or molecular mass of the entire compound. So we're going to find the formula mass, K2CO3. So the first thing we need to do is find out what the mass of potassium is. Potassium is 39.10. We always round it to 2 decimal places. And there are 2 potassiums. So for our potassium, it is going to be 2 times 39.10. Carbon is next, and we only have 1 carbon, so it'll be 1 times. Carbon is 12.01. And then lastly, oxygen. We have 3 oxygens, so we're going to do 3 times. Oxygen is 15.999. That last 9 makes this 9 go up, which makes this 9 go up, which makes this 5 go to a 6. So it's 16.00. If we add all of those up together, 2 times 39, that is 78.2. 1 times 12.01 is 12.01. And 3 times 16 is 48.00. We add all of those up together, and we get 138.21 grams per mole, or AMUs. Third step, you divide the total mass of the element whose percentage you are looking for by the total mass of the entire compound. Then you multiply the result by 100 to convert to a percentage. So the first one, we're going to find out what the percentage of potassium is in potassium carbonate. Now our potassium, if you remember on the previous slide, was 39.10. We're going to have 2 times 39.10. That is the total mass of the element we're looking for. We're looking for potassium, and we're going to divide that by the total mass of the entire compound, which was 138.21. Then we multiply the result by 100. And that happens to be 56.58% potassium in potassium carbonate. Now let's find out what the percentage of carbon is in potassium carbonate. Well, we have one carbon, so we're going to say 1 times the molecular mass, or the atomic mass, the molar mass of carbon, which is 12.01, divided by the total mass of the entire compound, which is 138.21. Then we multiply that by 100, and that is 8.69% carbon in potassium carbonate. Lastly, we need to find out what the percentage of oxygen is. We have 3 oxygens, so we're going to do 3 times the atomic mass of oxygen, which is 16. We're going to divide that by the total mass of the entire compound, which is 138.21 grams per mole. Then we're going to multiply that by 100, and that equals 34.73% oxygen in potassium carbonate. Last step is, since there are no significant digits given in the problem, we're going to round our answer to 2 decimal places and add the percent sign as the label. Now I would like for you to pause the video and try the next practice problem on your own, and then come back and check your answer. Okay, go ahead and check your answer. Now I would like for you to pause the video and try this next practice problem on your own, the last one, and then come back and check your answer. Okay, go ahead and check your answers here.